Professor Alinda Kiss, and I am going to be one of the instructors teaching in your Time Value Money Corporate Finance First course. So what I'd like to do today is introduce you to the course and introduce you to a very important concept, time value of money. Now, as you know, this session's recorded, so you'll be able to watch it, and you'll probably want to look at it and review again the material before you start the class. So this is approximately what the course homepage will look like. I've been working on this homepage with the Pearson people, and you can see that you've got on the left, I've got the homepage and links to different items in the course, like how to get into Zoom, and in the center here we have the different weeks, and so you can see we're going to start off with time value of money, continuing what we've done in opening residency, continuing that into week 2, and then talk about something known as investment decision rules. You may have heard of Npv and IRR. That's what we're talking about here. Next, we're going to talk about capital budgeting, where you're going to look at what's the relevant cash flows and figure out if a project makes sense. And then we value stocks and bonds and introduce interest rates. Week 5 is risk and return, where we talk about the fact that if you're going to have a lot of risk, you want to get compensated with a higher return. Week 6 will be valuing bonds, and we will be looking at the cost of capital. And in week 7, we will have a review before week 7, and then you will have a final exam in class, and it will be on the Monday of week 7, which this year is December 7th, from 7 to 10 p.m. No matter when your class meets, everyone will take the exam at the same time. Now, before I tell you anything more about the course, I'd like to tell you a little bit about me. So I am going to show you me. As I said, my name is Alinda Kiss, and I have been a professor in the finance department since 2003. I received my PhD from the University of Rochester, undergrad, Washington University in St. Louis. And I have taught at a couple other universities, Temple, Wharton, Wellesley, as you can see. But most of my career has been in the private sector. Most recently with the Resolution Trust Corporation, which actually is the government sector. But before that, I was with a bank called PSFS, and before that with Citicorp Investment Bank. So I've been working in interest rate derivatives and managing portfolios, and with the RTC, I was a government regulator. I also worked at a commercial bank as a lender that's now part of Wells Fargo, but it was First Pennsylvania Bank, and I've been a corporate treasurer of a manufacturing firm. So that is what's most relevant for this course. I've got my cell number on here and my email, and I'm going to ask you as a favor, please do not call between 11 p.m. and 7 a.m. Eastern Time. It's not so much you wake up me, but you wake up my husband, and you don't want to do that. I received, as most of the people who are talking with you today, most of the professors in the residency are recipients of teaching awards, and I have received a few myself. Now, on the slides, I also have information on my colleagues who will be teaching the course with me, and you can read about them. So let me go back to talking about the course. So I strongly recommend that you read the Wall Street Journal, and I've got a link for where you can get the Wall Street Journal at a student rate for 4 weeks, $4, and You don't have to buy it through us if you have another source for the Wall Street Journal. Now, the textbook has 2 chapters related to time value of money. We have some videos related to chapter 3. I'm going to talk about just 2 concepts in there. I think you can manage this on your own. But in chapter 4, I'm going to tell you what we're going to be doing today. We're going to compute the future value of an investment made today, the present value of cash to be received at some future date, how to calculate the return on an investment, compute the number of periods that equates a present value and a future value if you have an interest rate, find a payment such as if you have a mortgage or automobile payment, the present value of a stream of both even and uneven cash flows, and pricing a bond. And then we're going to talk about the concept I mentioned earlier, net present value of the benefits minus present value of the costs. And in this course, we're going to be using spreadsheets to solve time value of money problems. So I want to make sure you can use the functions in Excel. We give you a little Excel course you're supposed to take. I'll go through with you a few of those functions today. And I've asked that you all have Excel open. So I mentioned a couple things in chapter 3 is cost-benefit analysis. You want to compare costs and benefits if they occur at different points in time, or different currencies, or different commodities, or have different risks. We must put them all in common terms. So typically what we would do is convert costs and benefits into cash value today. Now, if we were doing this residency in person, I would have asked for you all to have a piece of candy. And you'll notice I'm looking at Hershey's chocolates because that is a Hershey Kiss. And what is my name? Alinda Kiss. So I want to help you remember. I'm sorry I can't give you a piece of candy today. But I would like to ask you a question. How many of you would prefer 1 piece of candy or 2 pieces of candy? So if you would prefer 1, just raise your hand. If you would prefer 2, raise both hands. Okay. So most of you, unless you don't like chocolate, and I realize it's 8 in the morning, you might not want, would prefer 2. But what if I said, I'll take back your 1 piece of candy and give you 2 pieces? Would you accept? And I assume that most of you again would say yes. But what if I tell you, I'll take back the candy I gave you today, but give you your 2 pieces a year from today? Now, would you accept? Probably not. Not want to wait a year for the candy. So, what if I give you a choice of $100,000 today or $105,000 today? Which would you choose? How many choose the 100? How many choose the 105? Both today, of course. We all want the more money today. But what if I offer you $100,000 today or $105,000 in 1 year? What information do you need to make this choice? Yes, you need a rate. So you don't have to open your computer to Excel, but it would be useful if you could. I will be sharing my screen and sharing the Excel with you, and I sent you an email telling you how you open half of it, and so I hope you've done that. So consider an investment opportunity with the following certain cash flows. $100,000 today is the cost. The benefit is $105,000 a year from today. So the difference in value between money today and money in the future is due to the time value of money. And we use PV for present value, FV for future value. So the rate at which we can exchange the money today for money in the future is determined by the current interest rate. Suppose the current interest rate, annual compounding, make it simple, is 7%. By investing or borrowing at this rate, we can exchange $1.07 in 1 year for $1 today. So if the interest rate is 7%, we can express our cost as $100,000 today times $1.07 a year from today over dollars today, or 107,000 1 year from today. So a year from today, are you willing to pay 107,000 to get 105,000? I didn't think so. Now, we also could look at that then in what's our net present value. Our benefit is the 105,000. Our cost is 107,000. So a year from today, it's worth negative 2,000. In other words, we could earn 2,000 more in 1 year by putting our 100,000 in the bank rather than making this investment. So we should reject the investment. Now, we could look at everything in values today, in dollars today, by taking that 105,000 a year from today and dividing it by 1.07. This is the amount that the bank would lend to us today if we promised to repay 105,000 in 1 year. So what does that equal? That's $98,134.84 today. So we can now compute the net value of this investment as well. $98,130.84 is the benefit. $100,000 today is the cost. So in today's dollars, that's worth negative $1869.16. We should reject. We see a negative result in today's dollars. Earlier, we saw a negative result in future values. So this demonstrates that our decision is the same whether we express the value of our investment in terms of dollars a year from today or dollars today. So negative $1869.16 times 1.07 gives us negative 2,000. These two results are equivalent, but expressed at values at different points in time. Does anyone have any questions? When we express the value in terms of dollars today, we called it the present value. If we express it in terms of dollars in the future, we call it the future value. And we can take that 1.07 and divide it by 1 divided by 1.07 gives us this discount factor of 0.93458. 1 plus 0.07 is our compounding factor. Now, I mentioned net present value before. The net present value of a project or an investment is the difference between the present value of its benefits and the present value of its cost. Net present value is equal to the present value of all the project's cash flows. When we make an investment decision and we have alternatives, what we call mutually exclusive projects, we want to choose the alternative with the highest net present value. That's choosing this alternative is equivalent to receiving its net present value in cash today. Now, I put a little note to you. If you look at my notes page, you can see what factors influence the level of interest rate. So I'm just going to quickly go here and show you, view the notes page. And up here, those are my choices. View notes page. And you can see what influences the level of interest rates. Let's go back to viewing normal and back to the slideshow from current slide. All right. If we're not constrained and we can do every project that we want, we would accept any project with a positive net present value because accepting them is equivalent to receiving their net present value in cash today. But we will reject projects with negative net present value because accepting those projects would reduce the wealth of the investors in our company. We can also use the NPV decision rule to choose among projects. To do so, we must compute the net present value of each alternative, and as I said before, select the one with the highest NPV. This is the one which will lead to the largest increase in the value of the firm. And as I mentioned earlier, that means when projects are mutually exclusive and we won't accept all of them, we choose the one with the highest NPV. And you will be having a problem to do where you need to calculate which is the project among mutually exclusive ones in the homework that we have. Now, you got a letter from me talking about the fact that we have my lab, my finance lab. We also, and those are regular homework problems, but we also have what we call guided readings. And they are due before each class. So you have to do before the first class, which will be before noon on Monday, October 19th, you will be answering questions in the first guided reading. You'll be submitting that in Canvas. You also will be taking the Harvard Intro course. And I recommend if you have some time, do it now, because it may take you a while, especially if you don't have a background in finance. So now I'm going to talk in Chapter 4, which is where the bulk of this is. I showed you earlier, present value is early money on a timeline. Future value is later money on a timeline. Interest rate is the exchange rate between earlier money and later money. And we call this term interest rate, we also call it the discount rate, the cost of capital, the opportunity cost of capital, the required return, the yield, and the hurdle rate. So we give it all a lot of different names for that rate. I want to mention to you, if you get $1 and you can compound for 22 years at 20%, that dollar will grow to $40. If you don't earn any interest on it, your interest rate is 0%, at the end of 20 years, you're only going to have $1. If the rate is 15%, you're going to have a bit more, 10%, a little bit less. So what's happening here is you've got let's not look at $1, but $1,000. Your original $1,000 is sitting there. You're earning interest on that original $1,000, and the advantage of compound interest is that you're earning interest on your interest. Now, I mentioned to you that there are a number of formulas we're going to use in Excel. These are the formulas here on my slide 23, and I hope you've all downloaded my slides. So, future value, it's a function of the rate, the number of periods, the payment, and the present value. And I put a minus sign with the present value there because I wanted to get my future value as a positive number. If I had positive sign, it would compute a negative number. And I do that with present value because the logic is future value is the benefit we're getting. Present value is the money we're spending to get it. So as a consequence, I usually put that in as a negative. If we're solving for rate or number of periods or payment, we must have present value and future value of opposite signs, or we're going to get nonsense. And I'll show you that as we work through some practice problems together. The number of periods, that's what MPER stands for, has rate, payment, minus present value, future value. Payment has rate, number of periods, minus present value, future value. Net present value, here we don't need to put in negative numbers. We put in the rate and then the series of cash flows. We use this function for the present value of a stream of uneven cash flows. For internal rate of return, we start our cash flows at period 0 and we put all of them in. With the NPV, we have to start our function with cash flow 1. We have to subtract our initial outflow after we get the number. Excel just does not give you the NPV with their NPV function. Now I want to mention something else. Notice that except for when we're solving for rate or internal rate of return, which is also a rate, the very first thing we put in here is rate. Now, if you clicked on this Excel, and you can do that on your own, you'll see I bring up the file that I've asked you to have open as well. Now, let's just go a brief refresher. If we're looking at the present value of a single payment, the present value, remember, was the future value divided by 1 plus r to the t power, or the number of periods, and in our example before, it was 1. Now, we can work with a financial calculator if you want as a check for yourself, but we're going to be working everything in Excel. So there were 4 parts to this equation: present value, future value, rate, and number of periods. If we know any 3 of them, we can solve for the 4th. So sometimes if we know a present value and a future value, we want to see what is the implied return. So we can rearrange, and if we take the future value divided by the present value rate and take the teeth root of that and subtract 1, we can find it. But it's so much easier to do Excel. I just want to show you the math behind it. So now let's look very briefly here. If you have an investment that's going to pay you $1,200 in 5 years and you invest $1,000 today, we can work it out and we'll see it's 3.714%. But if I go to Excel here, and I am got a blank worksheet to open here, I can put in the numbers. So we said that we have for rate, we're solving for rate. So the number of periods is 5, nothing for payment. Present value, it will put in minus 1,000, because I'll watch if I don't put in the minus, and 1,200 for the future value. And now I'm going to use the rate function. So I click on function and I start typing, and you can all work on with me if you want, or you could just watch me now. I'll type in rate, and I click go, and I click OK, and it tells me to put in the number of periods. I put in 5. Payment, I said, was 0. Present value was 1,000, and future value is 1,200. And if I click OK, you'll see it gives me an error message. Why? I didn't have the minus sign. So I'm going to put in a minus sign here by my present value, and now it tells me 4%. Well, I said it is 3.714%. So why is it telling me 4? Because the default is to give me 0 places after the decimal. If I want more places after the decimal, you can see I'm in percent. Over to the right, I can decrease. Over to the left, I can increase. And I can get as many places after the decimal as I want. So here's how I did it in Excel. And as I said, remember to have the negative sign for present value. Now, something to mention, I've already told you about that. Now, we can do this with a financial calculator, which we're not going to do, but I do have the slides to show you that we get the same answer. Now, if we were solving for the number of periods and we didn't have Excel or a financial calculator, we'd have to use logs. I don't know if any of you ever used a slide rule. When I took physics in college, we used slide rules, and that's basically log tables. So much easier to use Excel. Now, here is a problem with the solving for the number of periods. You want to purchase a new car. You're willing to pay $30,000. If you can invest at 10% a year and you have $15,000, how long will it be if you have enough money to pay cash for the car? So now, as I said, I'm not going to try to do it without Excel. I'm solving for the number of periods, and I'm putting down the fact that I want minus the present value, positive the future value. So here, I'm saying 10% is the rate. I'm not putting any money per year. I'm just going to start with $15,000, and I want to know how long will it take to grow to $30,000. So I'm telling you answer is 7.27 years, and let's solve for that. So what I have here, I said the rate was 10%, and I said no payment. Present value, I said, was $15,000, and future value, I said, was $30,000. And now I'm going to solve for the number of periods. So I'm going to go function, and I'm going to start typing NPER, and I'm going to click go. And now it gives me the choice number of periods, and I said yes. And again, my rate here is 10%. I could either put in 10% or I could put in 0.1. Payment 0, present value. And again, if I didn't put in negative, I would have an opposite problem, minus 15,000. And I want to grow to 30,000. And I click OK, and it gave me 7.27. It gives me 2 places after the decimal as the default here. Now, we can use these functions to find the present value, future value of a set of cash flows. Setting up the data is half the battle. If it's set up properly, then you can just copy the formulas. So now I have here, what if you've got an investment that will pay you $1,000 in 1 year, $3,000 in 2 years, $5,000 in 3 years, $7,000 in 4 years, and $9,000 in 5 years. If you want to earn 15% on your money, how much are you willing to pay? So now we cannot use the present value function unless we want to do each one individually. And I show you that in the Excel that I told you to download. But let's just use the Npv function. And remember what I told you. That does not calculate the Npv. It gives you the present value of a stream of uneven cash flows beginning in period 1. So now I'm going to be solving, as I said, for Npv. So let me just put Npv out over here. And I am going to look at a series of cash flows. So I'm going to look at periods 1, 2, 3, 4, and 5. And I said we're looking at getting 1,000, 3,000, 5,000, 7,000, and 9,000. And now I'm going to use the Npv function. So I go up here and I click on function, and I'll type Npv and click go. And it gives me some choices, and I'm choosing the one that's Npv. Now the rate that I said I wanted to earn is 15%, right? So I'll put in 15%. Now, I can type in each of the values, or when I get here, I can just drag this across here and do it that way, and it gives me an answer. And it gives me an answer with 2 places after the decimal. This is worth $14,902.44. Now I've got another NPV problem here for you. Your broker calls you and tells you he has this great investment opportunity. If you invest $1,000 today, you'll receive $400 in 1 year and $750 in 2 years. If you require a 10% return, a 15% return, is it worth it? Now, so here I've just got 2 cash flows, $400 and $750. Now I'm going to use again my Npv function. So I'm going to use it, and it was just there. I don't have to type anything, go. And now, again, I said I want a 15% rate. Don't just put 15. And since I have only 2 values, I might just as well type them in. And I click OK, and I get an answer of $914.93. Well, that's not the NPV, of course. That's the present value of these cash flows. To actually get the NPV, I would take this number and I would subtract my cost, which we said was $1,000. And you can see it's negative. So I don't want it. It's charging more than we're willing to pay. Now the next thing I want to talk about is annuities and perpetuities. An annuity is a finite series of equal payments that occurs at regular intervals. Typically, the payment is at the end of the period, and we call that an ordinary annuity. If the payment occurs at the beginning, it's known as an annuity due. Any of you have something for which you have to make regular payments at the beginning of a month? Well, we own a home, so we don't, but did anyone ever pay rent? Don't you usually pay rent before you live for that month in the apartment? So if you want to look at the value of what you're paying for the year, that would be an annuity due. And a perpetuity is an infinite series of equal payments. Now, with a perpetuity, you must use formulas. There is no Excel to get the value of a perpetuity. So the perpetuity, the present value of the cash flows, they're the same forever. Cash flow C divided by the required return. If you have a growing perpetuity, the present value is the cash flow that you're going to get a year from today divided by the required return minus the growth rate. We will use the formula for the growing perpetuity to price constant growth stock in week 4. We'll use the present value of an annuity along with the present value of a single payment to price a bond. Now, I've given you formulas for annuities. The textbook gives it to you, but we don't require you to use formulas for anything except for the 2 types of perpetuities. Now, let's just do a couple more problems. Let's go looking at where you want to find the value of a payment. Suppose you want to borrow $30,000 for a new car, and suppose the rate is at 9% a year, not where rates are now, but it's compounded monthly. 9% a year works out to be 0.75% a month. If you take a 4-year loan, what's your monthly payment? Remember, the payment function is a function of the rate, the number of periods, the present value, and the future value. So the number of periods is 4 years, 12 months in a year, that's 48. So it's a payment of 0.0078 or 0.0075 or 0.75%, 48 periods, 30,000 and 0. And since the future value is 0, I don't have to put in the present value as with a negative because I've got a future value here of 0. But watch what I get for my payment. I get a negative number. And that kind of makes sense. We're going to be making these monthly payments every month, whereas we're getting today a car that's worth $30,000 till we take it off the lot. Now, one of the last worksheets of the Excel workbook, I did an amortization table for a 30-year mortgage at 6%. 6% is 0.5% per month. Now, the rates now are less than 3, so you could work the same problem, and instead of 6%, use 3% or whatever the rate is. If with 3%, it would be 0.0025, and maybe we'll work that one through together. 360 payments, and here a $500,000 house, or a bigger house than that if you're going to take out the mortgage of $500,000. But in my example, your monthly payment is $2,997.75. And what you will see when you look at that you're actually going to pay more in interest than you will have actually made of payments for principal. So as I said, you can try changing the rate, try repaying in 15 years and see what happens to payments and to total interest paid. And we will probably ask you exam questions where you have to do that. At least we have in the past. Now I want to talk about pricing a bond. We can combine the present value of a single payment with the present value of an annuity to price a bond. A bond is a series of annual or semi-annual payments known as coupon payments, plus a return of principal at the maturity of the bond. So we're going to look at a bond that has a face or par value of $1,000 and pays $50 every 6 months. It matures in 10 years, which is 26-month periods. We're going to calculate the value of the bond today if the periodic interest rate is 2%, 5%, or 7%, and we'll use the present value function in Excel. The periodic rate is every 6-month rate. The annual rates would be 4, 10, and 14. So here at 2%, it's the present value of 2%, 20 periods, 50, and 1,000. And that works out to be $1,490.54. That's what you would pay for this bond if interest rates are at 2% every 6 months. Notice you're paying above the face value of 1,000. If we're looking at 5%, you're going to find the value is 1,000, and at 7%, you're going to want to pay less than 1,000 in order to earn that 7%. And so I'll just quickly show you this. I've given you, let's just do real quickly this one. So the rate here we said is 7%, and the pay number of periods we said is 20. And we said that we get a payment every period of 50, and the future value is 1,200, and we're going to solve for the present value. So function, present value, click, and I've got it here already, so click OK. Rate, 7%. Number of periods, 20. Payment, 50. Future value, 1,000. and I click OK, and you can see that I've got a negative number because I put in everything else as positive. If I wanted to see that as a positive number, I can put a minus sign out here. It would cost me $788.12. And I have the answers note page. As I mentioned, when the rate was 2%, it sold for more than $1,000. When it was 5%, it sold at exactly $1,000. When the rate was 7%, the bond sold for less than $1,000. So we will discuss bond pricing in week 6 and in more detail in corporate finance too. On the next slide is a photo of a bearer bond showing the coupons. So you can see this is a bearer bond. It's also a municipal bond. It matured in 2009, and you can see I took a photo of this. Was a bond I actually owned, and every 6 months I would take to the bank this the bond and cut out this coupon, and I would get $181.25. And then in January 2009, get back my principal of $5,000. You're going to actually use this bond in an interactive exercise and price it. Now let's look at a problem very simply. Suppose the government offers to sell you a bond for $613.81. You're not going to get any payments until it matures in 10 years, and then you're going to get $1,000. What rate would you earn if you bought this bond at the offer price? Now, this is known as a zero coupon bond, and because it's not paying any coupon payments. So here we can solve in Excel, and we would get the rate 5%. Now there's some 3 rules here. You can read that on your own of valuing cash flows, but we have to have them in the same period of time. If we want a future value, we compound. We want a present value, we discount. Now we're going to work on some problems on your own. I hope you did them before class, and then you were going to take about a 10-minute break now, so you can do whatever you need to do. Get a cup of coffee, glass of water, use the facilities, and then we're going to work through some problems. And we've got these, and then if we have some time at the end, I'll work through these last few problems. If I don't, I've made a recording of these, and I've got the answers here for you. And again, information about me and my colleagues, Sayed Baiju, who has been teaching in our program since 2012, and he works at Capital One Bank in risk governance. And Joel Baiju, who first taught with us last year, but he was a tenured professor at University of Massachusetts and been a friend of mine since 1989. We both were bank economists together. So let's take a break. Thank you.